Okay, I think we'll kick this off. Good morning, everyone. Welcome to this webcast for the new What's New in Creo 5 Root Solutions presentation. We have a ton of stuff to get through today, so I'm going to make this intro pretty quick and get over to the good stuff that I know you're all here to see. Hello to everyone that's joining us live. We will be posting this up on YouTube afterwards, so hello future people as well. Hopefully you enjoy the presentation. I'm James Brooks. A lot of you have met me before down the years, Business Development Manager here at Root Solutions. I'm joined today by Rory Ireland-Bowcott, our Pre-Sales Applications Engineer and all-round Creo guru. He'll be doing the hard bit today. He's got a huge amount of information to get through with you. So without further ado, let's have a look at the agenda. So today we're going to have a look at some of the useful bits and bobs which are in the core modeling enhancements. We'll also have a look at some of the new sparkly, flashy extensions which are coming out, such as topology optimization, additive manufacturing. We've also improved NC, so subtractive manufacturing as well as looking at modeling, sheet metal, detailing, and so on. So we'll go through all of these. Now, throughout the presentation, you'll have the opportunity to ask questions through the interface with the GoToWebinar tools. Please do put lots of your questions in. We will get back to all of you, and we'll send a copy of all the questions that have been answered to everyone that's attended today. And if you're watching the replay, we'll get a copy of those to you on request. Simply email info or your sales contact to get a copy of that. Before we go too much further, I am going to ask you very quickly to do a couple of polls with us. These are super useful for us. They really help us to help you with things like updates and information and so on. Oh, just got a bit of a object there. Right, so the first poll that I'm going to run for you is just a quick question on which version of Creo are you currently using? Is it Creo 1, Creo 2, Creo 3, Creo 4? Some of you may already be on Creo 5. I didn't put that on the list, unfortunately. But if you could all quickly vote on that, that would be fantastic, and that will just help us to get the right information across to you after the event. Okie dokie, 92% voted, a couple more. Okay, I'm just going to close that poll very quickly here, and I'm just going to share that with you. So, interesting, a lot of you are on Creo 4, so you've been keeping up with the updates. Creo 3, about a third of you. Those of you on Creo 2, you may be aware that Creo 2 has actually gone end of life with the release of Creo 5. So yes, possibilities for you there to upgrade. I know some of you are held back by things like working with other customers that are using Creo 2 and Windchill and the like, but that's quite interesting for us, which is good. Thank you very much. And the second poll that I'm going to run is just a quick thing for us, really. We're running this Creo launch as a webcast. In the past, we've always done it as a live event. We've hired a venue and invited you all down, networking and so on. But just wondering what you prefer and how you would like us to do this in the future. So if you like live events, vote there, or if you prefer the webcast, it does give us the opportunity to record it, post it later, which is always good. But yeah, just curious to know what your feeling is on that, and then we'll act accordingly. May do a combination of both. But that's good. I see the votes coming in now. Wonderful, thank you very much, and I'll just share that with the group as well. So yeah, the majority enjoy webcasts, which is good. Okay, well, yeah, message received. We'll certainly invest more into webcasts in the future. Fantastic. Right, let's crack on with the presentation. So at this point, I'm going to hand over to Rory. Just as a word of warning, Rory had 3 days worth of Creo 5 training, and he's tried to condense this down to an hour. So we're going to try our very hardest to make sure that we fit it all into this hour. And yeah, we'll be jumping around here, there, and everywhere. Lots of different applications and tools he's going to be showing off. And at the end of that, we'll jump back. If we have time for questions, I'll go through them with you. If not, then like I say, we will make sure that everybody gets a copy of the questions that have been asked, fully answered, and they're available on request. Right, okay, over to Rory.
Okay, thank you, James. Welcome, everybody.
As James said, we have a lot of stuff to get through today, so I'm going to jump straight into it. If it seems like I'm powering through the slides, it's probably because I am. So we'll start off then. Just a quick couple of things on installation, okay? So when installing Creo Parametric, you now have a little tooltip, okay? So as you hover over individual items in that installation, you get a bit of information about what you're installing, okay? That's going to be really helpful for those new users. Any of you that implement Creo across multiple systems may use the silent install or uninstall process. Now when you're uninstalling using the silent uninstall process, you will get a progress bar, okay, so you can actually see where you're up to. Those are the rest of us that install locally. Now when you go to uninstall a version of Creo, okay, you get alongside all the other applications as well. You can uninstall everything to do with that data Creo in that date code of Creo in one go. Okay, no longer do you have to uninstall each individual item. Okay, so user interface and some experience updates then. So first things first, mini toolbar, okay, that's been pushed out. It was introduced in Creo 4 and it's been pushed out further into various different applications. So both in the 2D and 3D side of Creo for annotations, the style feature, and round and chamfer handling as well. Okay, so you'll see that utilized a lot more. Modernized appearance then, so we've got updated drag handles and improved anti-aliasing for things like texts and lines. Okay, I'm going to show that as we go through. And a couple of nice little tweaks for the model tree then. So we've got a couple of new options for show only, show all except. Okay, you don't have to use simplify reps anymore. We've got those under the right hand mouse button. With the search filter then in the model tree, okay, we always been able to search the assembly level model tree. We can now search at part level. So if you've got particular features you want to find, you can interrogate that search bar and find those parts that you want to get hold of. A quick note on augmented reality here. We'll probably do a separate video on this, but in Creo 5 they've introduced Creo AR Design Share. So in Creo 4 we introduced the ability to export your models as AR experiences, so you had up to 5 of those. With AR Design Share, it gives you a little bit more flexibility. You can upload more models and you can also protect that information, so you can send it out just to individual users. Okay, you don't have to send it out to everyone. You can tailor it, you can password protect it and so on, but I say we'll probably cover that in a separate video. So we'll move on now. Next page, and we'll take a look at some of the modeling improvements, okay, and then we'll run into a bit of a demo. So first thing then is the addition of a 3D sweep, okay, so if you work with machined parts and cutting tools, this is going to give you that accurate geometry you've been needing, okay. We've been lacking this functionality. In Creo 5 it has now been introduced. Okay, editing drafts, okay, if you used to have rounds on your models, you go to draft it. That's a bit of a kick in the teeth at the moment. Creo 5, we've updated that. You can now handle those rounds and draft at the same time. We've also updated the mirror feature, okay? Being able to add and remove features to the mirror, as well as getting fully defined previews. When it comes to sketches, okay, we can now pick out an individual sketch region, so individual loops within a single sketch you can now operate and act upon individually, so things like extruding or revolving individual areas of a sketch. Now we will cover that in the demonstration, so we'll move on. A couple of updates to visuals, so glyphs and previewing while dragging a dimension has been updated, and point patterns have seen a bit of an improvement as well. They always used to be a bit of a pain. If you took a feature and you point patterned it, the coordinate system always used to move around and your part used to be in a slightly different position. That's been improved, changed in Creo 5, and we've also got a slightly new UI for that as well. If there's any surfacing people amongst us, you may have used FREESTYLE. I hope you have. It's a really good tool. We've improved that. We now get previews. So in Creo 4 we had the ability to import OBJ files. We now have the ability to preview that geometry before we utilize it. And we've also introduced box mode. So if any of you use Rhino or any other sort of mesh modeler, that should feel fairly familiar to you. Being able to split up a mesh now. So we can do that using the datum plane. Okay, so we can split a mesh along along a plane. And finally then aligning FREESTYLE geometry. Okay, we can now align to non-G2 chains. So if you've got a sketch that's not tangent, you can now align your FREESTYLE geometry to that, whereas before you couldn't. style then, so any of you users that use ISDX, we've got a few tweaks in ISDX here. We've got the ability to create mirrored curves. Okay, so selecting a mirroring plane, you can create an identical curve the other side of that mirror. When creating surfaces, if you're working with a loft or something along those lines, you can now flip the direction of that loft. Okay, a little bugbear of most people's. It was used to have to fiddle around with the drag handle. Now there is just a flip option for changing that. And finally, resolve mode. If you're working within style and you've got a fail feature, one of the biggest improvements for myself here is being able to exit that feature, that style feature, without having to fix that error. Okay, so you can get home and get to the pub without having to finish your work, which is quite nice. So I'm just going to run through a quick demonstration. Now, for the purposes of this webcast, I've recorded everything just so it keeps me all on track and within time. Everything is real time though. Anything that's not, I've mentioned on screen, or I will point out as we're going through. But it's just to keep me on track, really. So the data set we're using here is a Polaris snowmobile. Okay, it's been provided for us, and we're working within Creo 5. So the first thing I've just done there is swap over into perspective mode. So at any point now in Creo 5, you can toggle into perspective mode and start modeling. That's pretty much what we're going to be doing. So opening up the windscreen here, we're going to finish off modeling up this windscreen. So this is primarily consists of a couple of freestyle surfaces. So jumping into a freestyle feature here, I'm going to import a mesh. Now, we introduced this at Creo 4, but what we didn't have are these lovely little previews. Okay, so we can now see what the mesh is going to look like. We can view the normal direction. We have the ability to flip that over if we want to, and we can change the units in that insert option as well. Now, new feature for Creo 5 is box mode. Okay, so I said if you've used any mesh modelers before, or sort of breakdown mesh modelers, you will be pretty familiar with box mode. Okay, so you can now toggle that on and off within Creo 5. Just hide off a primitive shape there and do a big box select, and we're just going to crease up those edges. So not a new feature there, but it's a nice little one that we utilize quite a lot. And I'll just reduce the center crease there, and we'll end up with a nice smooth connection between those two. Okay, so the first major update for FREESTYLE then is being able to align geometry. Okay, and we can now align that to non-G2 curves, which I've just done there. Okay, so that curve there it's not got any tangent connections. It's just solid lines. Okay, so if I revert around to the points there, we can then manipulate that surface. So we've got a couple of datums on our mesh here that we're just going to align up with that that curve, okay, that predefined sketch. So we're going to use that as a bit of a skeleton to define the shape of this windscreen. Let's revert back around to the start here. We'll bring back in that original primitive shape, okay, and we'll unhide that. And again, just going to align another edge to our existing surface here. Okay, just snapping everything together to basically form one big quilt in a way. Okay, so that's pretty much our FREESTYLE stuff done. So we'll exit that. Because we're a parametric modeler, we've created those surfaces in FREESTYLE, but we can continue on working with these within the parametric environment now. So just going to extend out that surface, and you'll notice the new glyphs here. So the new drag handles and whatnot, a lot clearer, a lot easier to see, especially on these new high-res screens we're getting more and more of these days. So got our individual quilts here. We'll go through and merge all those together using that mini toolbar. Okay. So we'll just finish off this last one here. Okay, and now that we've got a completely formed quilt, we'll go through and mirror that. So the mirror tool itself has seen a bit of an update. Okay, we now get automatic previews on that mirror. Okay, at feature level, not just at part level now. And we'll come back to the mirror in a second as well, just to show off some extra features that have been added into that. But for now, we'll merge these two quilts, and we'll pop a round down the center of this windscreen just to make it a bit more uniform, but conform it slightly nicely. So round I'm going to be using here, I'm not sure if everyone's aware of it. I find it, I do quite a bit of training and not everyone's always aware, but we have a feature that we added in Creo 3 called a caudal round. Now at the moment this round is being defined by maintaining a constant radius, which makes it look a bit odd when you apply it off different angles and things. So swapping over to a caudal round there, rather than defining the radius, we define the overall width of the round, and Creo will adapt the radius to suit. Okay, so it gives us a nice uniform connection between those two quilts. we'll just finish off this part with a auto round, okay, so providing a different radius value for both the convex and concave corners there, okay, and we've then got our finished quilt, okay. So moving on from that, we'll just thicken that quilt out, okay, so we've got some solid geometry to work with, and then we'll show off some more new features, okay. So in the bottom right corner here, where we have our selection filters within Creo, we've got a new option within those selection filters, okay, so just in this bottom right, we've got sketch region. Now what that enables us to do is pick out individual loop surfaces within a sketch, okay, so you can have one sketch with lots of different shapes on, and you can pick and choose which parts of that sketch you want to modify or turn into a feature. So I've just done a big box select there on these components, we'll do an extrude, and we're just going to remove that material for that bit of a cutout, okay. Hide off that sketch, and then what we'll do is we'll rotate round to the back of this model, where we're going to produce a bit of a lug, okay, on the mounting lug for the back of this windscreen shield here. So again, simple extrude using that region select, or that sketch region sketch, okay. What I'm going to do, again, we're going to mirror it, okay, we're going to mirror that component. Again, we've got our previews, and again, we're going to come back to that. So I've mirrored that feature. What I'm going to do is roll back the model tree before that and basically simulate some design changes here, okay. So first thing I'm going to do is I'm going to add in a round, okay, so just selecting two surfaces here, we'll go in and add a round along the bottom of that boss. Now what we're going to do now is something we've always told you not to do, which is go in and draft that surface, okay. In Creo 5 we now have the ability to add draft to surfaces with rounds already applied, okay, so we're utilizing that flexible modeling technology that we have in order to do this. Again, it's still good practice to do your rounds at the end, but if you get in a sticky situation, you can always you've got that extra bit of flexibility in Creo 5 now. So final thing, add in a cut, okay, just to finish off this little bit of a boss. And now what we're going to do is we're going to bring that mirror back in. Now obviously that mirror has not been updated, okay, so in current versions of Creo you're probably going to have to delete that mirror, redo it, and work from there. Creo 5 now though, what we have the ability to do is reapply that mirror. So we've got that little checkbox which we can check, and we can now go along our model tree, hold control, and add back in those features. Now we've got a little feature, the round there is causing it to fail, so without leaving the mirror feature we can go in and redefine those references for our mirror geometry. Okay, that we're straight back into the mirror, we've got a fully defined preview, and we've now finished that component, okay. So there's some real nice little improvements to your day-to-day workflows when it comes to solid modeling. I say we haven't touched on all of them there, we've covered some of the main ones, so hopefully that's of use to you guys there. Okay, next thing then, we'll just have a quick look through CFD. So we have already done a little webinar on CFD. So I'm just going to show you some very basic CFD stuff here. Okay, just want to quickly mention a couple of different packages we have. So there are 3 packages for CFD. I say we're going to provide you with all these slides at the end, but I just want to get straight onto the demonstration here. Okay, so what I've got here, I say we're working with that Polaris data set. Okay, and I have it basically just a simplified version of this snowmobile, okay, purely for the the speed of the operation. We can go in and just run this simplified version. So CFD is fully integrated within Creo. It's not a separate system, okay, it's fully integrated. It's been developed by some the guys called Semerics. It's been custom created for Creo, okay. Now within CFD there are 4 main areas, okay. There are your physics, there are your domains, your boundary conditions, and then you have your results as well, okay. And the basic premise of what we do is we work our way down this list. So the first thing we're going to define are our physics, okay. Now these are the equations we're going to use to calculate our results, okay. So I'm going to bring across 2 here. I've got turbulence and streamline. Now turbulence is simply just the flow of air, and then streamline is basically the sort of simulation of adding in smoke, just visualizing that flow. Next then we need some solid bodies, so we're going over to our domains and we're just picking out the solid bodies from our model tree here, okay. We're going to add those into our simulation, okay. From there, then, what we want to do is we want to generate our mesh. Okay. Now, a couple of different types of mesh we can create here. In CFD, we can work both with interior volumes or exterior volumes. This is going to be an exterior volume. Okay. So we're going to utilize that, and I'm just going to adjust the bounding box that we're going to be working with in here. I want to simulate that this snowmobile sat on the floor, so we'll just adjust the Y factor just to simulate that that is going to be on the floor. So we'll now go and generate that mesh. Okay, and now this bit of the process I have sped up. So as you can see on screen there, the overall process took about 2.5 minutes. I'll make sure I'll pop all my computer specs on the questions feedback form, so you have all that. But as I say, it's a pretty quick meshing system. It's been generated by Cimerix themselves. It's custom created for this CFD application, and it's a very versatile and very effective meshing system. So first thing I'm just going to show you, so we've got our bounding box there, but what I'm just going to do, I'm going to jump down into the results section after I've hidden off my flow bodies and my cab bodies. I just want to show you the mesh that is created here. So on this front suspension unit here, I'm just going to go in and turn on the grid, and that will enable you to see the mesh. Okay, so you can primarily see it's made up of blocks, and where the meshing algorithm can't use blocks, it then breaks them down into further smaller elements. Okay, so blocks are obviously the quickest at computing, so that's what we're using here. Okay, so next then, we're pretty much all set up here. So the final things we just want to do is we just want to set up our bounding box. Now, by default, Creo will set all our bounding boundary conditions to just static walls. Obviously, that's not what we want. So this front face here, we're going to give that a specified velocity. Okay, so we're going to give that air some movement in a Cartesian arrangement. So we'll just go minus 20 meters per second along the z-axis there, and then this back face, we're going to say we'll have a specified pressure outlet. Okay, and we'll set that to 101,325, which is just 1 atmosphere in pascals. Okay. Now I did forget to go and add in my streamlines here, so I'm going to release some particles on that front face, and that'll simulate the flow of the smoke sort of running through our model and actually give us something to look at. Okay. So as to regards setup for CFD for a basic flow analysis, we are pretty much done now. So what we can go ahead and do is we can start that simulation. So we can just click Run up in the top here. And one thing that's quite unique to the CFD package is as soon as you start running that simulation, we can start viewing the results. Okay, so I can come down onto my streamlines here, and I can automatically start to see the simulation in progress. Okay. Now, obviously, it's still running in the background, and we're still reaching a convergence until we hit a nice point in the simulation. But I can immediately start investigating this information on screen. Okay, so I can go in and change things like the line thickness. I can add an animation step in, but at the moment we're not viewing anything, so I can go in and change that, and I can check out the velocity. Okay, and we get a little scale in the top right, which we can go and adjust the maximum and minimum values on that and interrogate that information. Okay, so that's purely just the flow of air running through the model at the moment. Let's say we wanted to investigate a particular element of this model. Okay, I can open up my boundaries in my results section here, and I can choose this front face, and I can then choose a variable that I want to see. So I can have a look at the pressure on that front face. Okay, and I can see again, I get my little scale to show me where the pressure is. And what I've just done there is I've turned that into a surface, and what that means is it will remain on screen while I'm doing other operations. So I can do things like go in and add a section and view the pressure along that cross section there. Okay. So as I said, a whole host of different tools here. This is a very, very basic simulation of what we could do in the CFD package. So we've already done a webcast on CFD. So if you haven't seen that, I advise you go and check that out. We had Phil Darlington in from PTC, and he ran through various different types of simulation within CFD in Creo 5. So have a look and check that out. But we'll move on to the next section now. So the next bit then is sheet metal, okay, and data exchange. So
first things first, bend reliefs, okay, they have seen an update alongside corner reliefs, okay, so we've got some new additions and new functionality in reliefs. I'm going to try and pick up the pace a little bit. I think we're running behind slightly. And improved conversion. So if you're starting off with a solid component and converting it into a SolidWorks, not a SolidWorks component, you want to convert it into a sheet metal component, but it doesn't have that uniform thickness. Creo 5 is a slightly more intelligent method of converting that that solid model, so you should find it a bit more streamlined in that sense. You won't have to do as much as a user. Chamfers, okay, rounded chamfer control on bend seams have seen an update, okay, and one quite nice thing here, within the flat pattern preview, we've always been able to create a family table instance of the flat pattern. In Creo 5, we can also now create a simplified representation of that flat pattern instance, okay. So data exchange then. So we now have the ability to import 3MF files, which are renowned in the additive manufacturing environment, okay. We have the ability to create profiles, so custom profiles for export into Creo view, so setting things like edge display and shade quality and all that good stuff. And finally, import validation has seen a bit of an update. So if you're bringing in step files, IGES files, it used to prompt up with a fair few errors. That's been tweaked and updated slightly, okay. Again, a bit more export information here. Step files have been updated to include the latest and greatest information, again for model-based definition as well, which we'll touch on in a bit. Finally then, update to our Unite technology. So this is the technology that we have to enable to bring in native CAD data from other CAD vendors such as SolidWorks and CATIA. We have extended that list to now include inventor data, okay. And here's a little table just to run through the various different types of data we can bring in and what we can do with them, okay. So I just want to show you some of that. Okay, so again, we'll jump into another demonstration here. So I'm going to open up a sub-assembly of this model, which is basically a bracket for mounting the battery on. Okay, I just want to show you how we can work with other CAD data. So if you've got a multi-CAD system at your workplace, or you just work with other vendors and they have different types of CAD data, you can work alongside them. So in the drop-down list, obviously we've got a pretty comprehensive list already of what we can bring into Creo here. But we've now extended that with the ability to bring in inventor data. So I've got a little assembly here, which is literally just a battery and it's mounting. Okay, and we're going to assemble that into my model. And we'll also bring in a Creo component. So this is a sheet metal component, which is just a bit of a guard for that battery. Okay, so we'll assemble that just using the coordinate system in place here. And as I said, what I really want to show you here is how we can sort of work and coincide with this inventor data. So I'm going to activate my sheet metal component here, and what I'm going to do is, first of all, I'm going to bring across some information from that inventor data. So using copy geometry, I'm going to bring across a couple of surfaces. So selecting that surface on the side of that battery there, I'm going to set the update control here to manual. I want to physically show you what's happening when we go in and update that data. Okay. The other data we're going to bring across is just this top surface here. Okay, so we're going to set that to provide a notification, which I'll show you. And now what I want to do, I want to modify this sheet metal form. Okay, so I want to modify the design intent. I want it to update in case my inventor data updates. So using flexible modeling here, we introduced flexible modeling for sheet metal in Creo 4. I'm basically going to redefine this end wall. Okay, and I'm going to define it utilizing that copied geom. And basically, I'm going to create an offset or a distance constraint. Okay, so we'll offset that 9 mil from that copied geometry there. On top then, what we're going to do, I'm just going to add in a sketched form, so utilizing just some basic sheet metal tools here. We'll go in and create a sketch, and utilizing that copied geometry again, we're just going to define that as a sketch loop. Okay, so we'll project that through and we'll create that sketch form there. Just tweak a couple of options on the form itself. So we'll get rid of the capped ends. We'll add in a bit of a taper to our model, and we'll pop a round on that placement edge. Okay. So we've made some very basic updates here, but it's enough to show you what we want to do. So what I'm going to do is just save the model at the top level here, and I'll jump out, and I'll erase not displayed from this assembly. Okay, so it's no longer in session within the CAD system. And I'm basically going to simulate some changes to the inventor data here. Okay, so I'm going to jump down into my data folder, okay, and find some already converted data. So this is the inventor data that's been modified, and I'm just going to copy and paste that and replace those files in my working directory. And that'll just simulate a change. Okay, so I'm going to reopen my assembly. And along with that change, now what you're going to see is Notification Center pop up. Okay, Creo is notified that there's a change made to this model. I can open up Notification Center. I can easily find out which component has changed, and I can go and interrogate that now. So under the right-hand mouse button, I'm going to go under Update Control here, and I'm just going to say Show Differences. So I'm not sure if everyone knows about this, but you can easily interrogate here what's actually changed in your model. So I've got two surfaces on there that I can easily see. So I've got my original surface there, and I've also got my new surface. So I can see that that's changed position, it's been updated. Okay, I can push that through and accept that change, and my sheet metal component now updates. Okay, I can do the exact same thing for my sketch form. Okay, I can see my old surface, I can see my new surface, and I can choose to push that update through. So that gives the user a lot of control over what's happening. And hopefully that should just sort of demonstrate how we can sort of collaborate with other CAD data systems. Okay, we can fully integrate their data into our Creo environment. Okay, then have a look at some detailing now. Then, so first of all, we'll just talk about model-based definition. Okay, so we can now query through our model as per ASME and ISO standards. Okay, so we've updated our querying capabilities. Date and feature symbols. Okay, we can now place those on geometric tolerances which have already been placed upon a dimension. Okay, that was a little bit of a bugbear for some people. That has been updated. Okay, creating downstream derivatives. Again, just referring back to the sort of the export. We are still in coexistence with the latest file format, so the latest step files to take across all your annotations and things you've added in to your model-based definition environment. Okay, radial dimensions have been improved. They're a lot simpler, a more straightforward UI in order to do so. Okay, failure diagnostics. Okay, if you've got something that fails in MBD, we've improved how we illustrate that information back to you. Okay, it's a lot clearer of what's going wrong. Say undo and redo operations now include more things as well. Okay, so you used to find that some things won't be undone with the undo redo operation. Hopefully now you should see that a lot inside model-based definition. Now GD&T Advisor, this was an extension that was released with the last release of Creo. I'm going to touch on this again. I'm not sure everyone's aware of it. It had pretty good upkeep. It's basically just a nice step-by-step guide for applying geometric tolerances. So it could be as useful with those of you that use geometric tolerances in your drawings. Okay, 2D improvements then. So radial dimensions. Okay, we've got an improved arrow states for radial dims. It's a lot easier to swap backwards and forwards between those. Okay, again, undo and redo operations like MBD now include things like annotations. So you should be able to utilize Control Z a bit more rather than having to delete and redo a certain operation. And again, improving upon Creo 4, again, we're utilizing the multi-threaded processes that we get these days. So those of you that are working with large assemblies should see a nice improvement in the performance of your drawings. With date and feature symbols now then, they never used to recognize duplicate symbols. Okay, we had syntax referencing for certain things, but not duplicates. Okay, so that's now been introduced. You'll be flagged up when you get those errors. Rotating notes, you can now hold shift to snap to specific angle intervals. Okay, and we have a config option for choosing your default cross-hatching type. Okay, I'll push through these though. Okay, getting tight for time again. So what I've got here then is a small assembly. Okay, and what we want to do here is we've got this little bracket in the middle. Okay, and at the end of the day, what we're trying to achieve is we're going to optimize this design. Okay, so I've jumped straight into a mechanism dynamics process within Creo here, and what I'm doing is I'm simulating a full sort of impact load on the bottom of the skid here. So I've got my springs and my dampers set up, and I'm going to push that load onto the bottom of the skid. I want to see how those forces interact with that bracket. Okay, and what I'm going to do with that information is I'm going to pull that information out of that bracket, which I'm choosing now. Okay, I'm going to specify the time frame at which I want to take a look at. So that's snapshot. So we'll take a look at it 2.5 seconds into that animation. And I can see there in that list all the forces that have been implemented into that bracket. Okay. And what I'm going to do with that information is I'm going to export all of those forces. Okay. So we're going to export those, and we're going to take that into a simulation. Okay. I want to see how this part performs under that stress load. Okay. So under applications, I say Creo Simulate is fully integrated within Creo. Those of you that don't have a full license still have access to the light version. Okay. So you can have a play around with that. But what I'm doing here, I'm bringing across those loads that we have. Okay. And at the moment, those loads are just assigned to points within the model. So that's not particularly useful to us. We want to go in and we want to assign those loads to the specific surfaces that they are relevant to. Okay, so I'll just show you the first one here, and I might skip on a bit just because we want to keep on schedule here. So we've assigned that load to that surface there. I can work through the next few there. So we'll just skip on. I don't want to sit and watch all of these, so I'll just skip on a little bit, make sure we cover those. So I'm just going through and assigning the loads to those individual faces. Okay, as you can see, we'll just finish up on that last one there. Okay, so with those loads in place, what we're going to do, I'm just going to run a new static. Now we do have various options within Creo Simulate. We can run static, modal, thermal, buckling, fatigue analysis. Okay, so we've got a huge scope of what we can analyze within Simulate. Here we are just looking at a static analysis though. So that's done. Okay, it's nice and quick within Creo Simulate, and now we're jumping into the results window. And it's worth noting, if you do have the light version of Simulate, okay, the results windows are exactly the same in the light version as in the full version. Okay, so you're not being restricted in what you're seeing at the other end. You're only restricted in what you can apply. So I've just turned off the animation on my stress window there, which is, I say, it's just showing the stress in this window, and that'll put the model in its sort of its maximum deformed state. Okay, and I can show where that maximum stress it is on that model. On the right hand side here, we've got displacement. Okay, and again, I can go and interrogate where my maximum displacement is. So say we run that simulation. What we're going to do in the end is we're going to go back and compare that to a topology optimized result. Okay, but before we finish up on this, I just want to jump into GD&T Advisor. So this was introduced at Creo 4. Okay, and it's basically a step-by-step assistant for applying geometric tolerances to your model. Okay. And it conforms to the latest both ASME and ISO standards. So if it's something you apply a lot on your drawings, okay, you've got a lot of geometric tolerances, this is going to be a guide that's going to keep you in line with all the latest updates and make sure you're working within the regulations. Okay, it'll free up your engineers to focus on what they need to do rather than worrying about if their standards are correct. Okay. So at the moment, I'm just running through and I'm just adding in a couple of extra tolerances to this model here. Okay, adding in a value, a couple of feature states, and we're just editing some existing tolerances on this model. Now, if we create a new tolerance here, what we go in and do is we choose the surface. Obviously, we want to go in and define. Creo will automatically generate a dimension for us, and if we pick on that dimension, we can choose a tolerance to work with. So we'll go for a symmetric tolerance here. We'll choose our number of decimal places, and we'll enter in our value. Now, from there, if we want to add in a geometric tolerance, we can use the drop-down list, and you see how these are color coordinated. So there's a green one there, there's a couple of white options, and there are a few that are grayed out. So that green option is the one that GD&T Advisor is advising you to do. Okay, it's the most applicable for the set of surfaces you've chosen. The ones that are in white are applicable for those surfaces, and you can utilize them. And then the ones that are grayed out aren't applicable for the type of surface set you've chosen. As you can see, GD&T Advisor is just going to guide us through those operations. Making changes is a fairly simple and straightforward process, and it really does just allow your engineers to be freed up and get through all of that stuff. Okay, I'll just let you finish off this last one here. Okay. So all we do now is do some rearranging of those annotations. I think we'll skip out this bit. So we want to keep on schedule. So we'll move on to the next section. So again, this is another paid for module. Okay, so the new extension for Creo 5 is one people have been waiting for quite a while, which is topology optimization. And we've got a few things here that kind of really set us apart from what's currently out there on the market. So hopefully you're going to enjoy this little bit here. So just one slide here at the moment, just talking about topology optimization. Okay, I'm just going to jump straight into the demo though. So first thing to note, when it comes to topology optimization, I'm just opening up the bracket that you've seen. It's a slightly cut down version. Okay, slightly more blocky. We want Creo to optimize the geometry. We don't want to confuse it with any of our ideas of what might be suited for those loads and stresses. So it's a very blocky model. But you'll notice that topology optimization is fully integrated within Creo. Okay, it's not a separate or disparate system. It's fully integrated within the Creo environment. Now what I'm highlighting here are just some volume regions, and they will become apparent later on, but they're just particular sections of the model, and I've just created those using like extrudes or revolves, or you can create them with a sweep, something like that. But it's just identifying particular areas of this model. Okay. Now we've already ran an analysis on this part, and we had some forces applied to it, and again we can bring those through into our optimization. Okay, so we've got some forces pulling through. If there's some forces we don't want, we can go in and suppress those off. Okay, we're not restricted to the ones we've got here. We can get rid of these, so we're just going to do here. And because we've got rid of those, what we can actually do in topology optimization, we can add in our own forces and our own constraints. Okay, so up top here in the left-hand side, you'll see we've got loads and constraints. So I'm going to add a couple of pin constraints in here. And it's worth noting you do not need a simulate license in order to do this. Okay, it's completely separate from simulate. Although you can bring your results through from your simulate analysis. Okay, but you do not need a license of simulate in order to add these forces and these constraints to your model within topology optimization. It's fully integrated. Okay, so we've got our loads and constraints set up there, as you can see in our model tree. And what we want to do is we want to form those basically into an analysis. Okay, so I've got kind of an existing one already here, and we're just going to add that constraint set into this analysis. And you can see up the top there in the type, we are running a structural analysis for this optimization. We also have the ability to do a thermal and one other, which I've forgotten, but I'll make sure I get back to you on that one. And modal, thanks James, so modal analysis as well. So what we're defining here is the topology region. Now this is where we're telling the computer what areas of the model it can play around with. So we're saying play around with the entire model, excluding those topology regions which we've highlighted there in blue. Okay, I'm also adding in a fabrication constraint, so I'm extruding material in one particular direction. So if you're doing any milling or casting, okay, you can avoid those undercuts in your operations. Okay. Now, in this optimization, we're analyzing for strain, so we're trying to minimize the strain based upon the loads and constraints that we've applied. Okay, so we've just chosen those in the list, and we're going to do that, and we're going to optimize our model by reducing the overall mass of this model. Okay, so we're going to start off with that upper bound limit. So we're going to start off at half the mass of the original item and whittle our way down from that in order to optimize our part. Now, final thing kind of almost to do is just review our settings. So we've got our topology regions there, we've got our design objectives, and we have our design constraints. Okay, so we can review that. And just before we finish, we've got our mesh. Okay, so we can control the mesh. We've gone in for a minimum or maximum element size here, and then we'll run our meshing system. So very similar to a simulate mesh here. Finally then, we can run our optimization. Now, I'm not going to run the optimization. This took about 2 to 3 minutes on my machine. Again, I'm going to post my machine specs on screen, but I'm just going to open up a pre-run optimization here and just show a couple of different things. So we've got our deformed state here compared to our original geometry. You can go and add things like oscillations and animations just to be a bit fancy. But there's a whole host of other things you can interrogate within this model here. Now I'm just going to pause the video. I'll jump on a bit and we'll run back. What really sets us apart from the rest of the competition here is what we do once we reach this stage. Okay, so we've got our faceted data here, which is useful in some respects. Okay, first of all, it's always in Creo. which is handy. But this faceted data is quite hard to work with. So PTC have worked really hard on getting this next bit up and running. So what we can do here is we can take this faceted data, we combine it with a freestyle surface to produce full BREP geometry, okay, that we can actually utilize and model around. So this is real time. It's taking that faceted data, it's overlaying a freestyle surface around it, and then it's going to produce us a solid model at the end of it, okay. So as you can see, it's all solidified in the model tree here. We've got our faceted feature. We've then got a freestyle surface, and at any point we can go back and we can edit that freestyle surface. So I can pick up on points and start pushing, pulling, and dragging them around like you always can with a freestyle surface. Now, one thing I would say is you're working with optimized geometry here, so I wouldn't advise going in and doing too much. Otherwise, you're kind of voiding your optimization that you've just ran, or you could be in danger of doing that. We've got multiple primitives within a freestyle feature, so we've got some holes in the middle of our model here. Now, if we're 3D printing, that's not too bad, but if we're not, we want to get rid of those. Okay. Hit OK, and our solid model updates. Okay. Now, as I said, what we've got is full BREP geometry, so we can just carry on modeling as if we were working with a standard Creo part, so a flexible modeling operation there to remove a cut, or I could go in and add a round or a chamfer on top of that component. Okay, but again, that's a very brief overview of topology optimization. We will probably maybe do a separate webcast on that, just covering some more aspects of that in detail. But we'll just finish up on here. I'm just going to open up that optimized component and compare that to the original component in a simulation. Now, what I will do, I'm just going to skip forwards through this. All I'm doing is opening up a predefined analysis on this component here and comparing that to the analysis we've just run on some of the others on that other component there. So I'm just going to skip this forward just to show you some of the results, so we can compare these next to each other. So we've got our new optimized shape on the left here, and we've got the original bracket that's on the snowmobile currently on the right hand side. So currently we're just viewing for stress. In the next window we're comparing displacement. Okay, so again, in Simulate you can open up both sets of results and really compare the two and see how your optimization is performing. Okay, additive manufacturing then. So again, this was introduced in Creo 4. Now, PTC's overall goal was always to have the full design cycle produced within Creo, and now at Creo 5 we are pretty much at that stage. So we can design our parts, we can optimize them, we can validate them, and now we can go through and 3D print them as well. Okay, so we've got that full loop without actually having to leave Creo. Okay, so you're not ending up with duplicate models or disparate systems. You're all within the Creo environment. Creo can connect directly to certain types of printers. Okay, and we also have access to online bureaus, so if you don't have your own printers, you can send your parts off over online and receive them back in the post. Okay. Now, Creo 5, we've introduced a new lattice type. So for creating lattices, we can create that, but I'm going to show that in a demonstration. And I'm also going to show a new extension, which is the extension for 3D printing with metal printers. Okay. So we'll quickly just run through some of this stuff now. So on screen here, what I've got is, again, that 3D printed, well, that bracket that we've optimized. Okay, it's got a few extra features in, but primarily it's exactly the same. So what I want to do is I just want to show off some of the new lattice functionality. Okay, so I'm going to define a void that I want to fill with a lattice structure. Okay, I'll reduce the scale of that and show off some of the new lattice types. Okay, so I'll drop down the cell tab. You can see a couple of new options in the beams. We've got outer truss beams and inner truss beams. We also have a truss shape. Okay, so these are new additions to the lattice structure for Creo 5. Now, like all previous lattice structures, we have the ability to modify all the parametric values that control that lattice structure. Okay, so we can still go back and do that. And what I'm doing here is I'm just going to change the cross-sectional size or vary the density of this lattice as it goes from left to right or right to left. Okay, and that's just going to show off the new taper beams within the model here. Okay, so I'll navigate around to the side and you can see how those beams taper. In Creo 4 they never used to do that. Okay, so as you can see, some nice smoother updates for the lattice structure there. Now I'm just going to go and delete that. And what I'm going to do is I'm going to prepare this model for a 3D print. Okay, so say in Creo 5 we now have the ability to talk to metal printers. So I'm simulating running a metal printer here, which I'm just going to choose from my drop down list. That will automatically change to my bed size. Creo knows what printer it is, it knows what type of printer it is, so it automatically adjusts all that information for you. I will scale down my part and I'll arrange that on the tray. Now, we've partnered up with a company called Materialize, and they now provide us, they're pretty renowned within the 3D printing world, and they provide us with all their support structures for each type of printer. Okay, so I can now click generate support and it will generate me a correct support for the printer I'm using. Okay, so there's a whole host of library support structures that Materialize have. We now have access to those. What we also have access to is all the parameters and information that go along with those support structures. So I can create a duplicate copy of that template here, give it a new name, okay, and I'm just going to drop down all the parameters here. So you can see we've got a whole host of a list of different parameters that we can go in and change there. It's pretty comprehensive, and we'll just go in and tweak a couple of different options here. So we'll change the spacing between the blocks there, and we'll get rid of our borders on this support structure. We can save that profile. You can have multiple profiles, and then we'll activate that and we'll regenerate our support structure. Okay, and then finally we just go in and validate that model. Okay, but that's not exactly changed from Creo 4. We can still analyze for thin walls, global interference checks and things like that. So we'll move on to our final subject here. Hopefully I haven't bamboozled you too much with all this information, but we'll get through it. So we're looking at some subtractive manufacturing now. So some updates on NC toolpaths. Okay, so highlighting, you can now show and hide your toolpaths on your model if you utilize any CMM. We've modernized the interface for that. Okay, and enhancements for calculating toolpaths. Okay, and the volumes and the parameters that are alongside that. For mold machining, we utilize that multi-threaded cores that we get these days again, so performance increase, and we've also introduced high-speed machining toolpath as well, which I'm going to show you now. So again, we'll jump into another demonstration. So in this model here, what I'm going to do, I'm just going to open up the windscreen. Okay, so it's slightly different to the windscreen I showed you right at the start here. The lugs are slightly different, but apart from that, it's pretty much the exact same component. So this is the component we're going to mold. Okay, so I'm just going to open up the mold assembly just to show you that. Okay, very basic mold. Okay, just two parts. We've got our cavity and we've got our core. Okay, and we're going to be working on the cavity aspect of this mold here. So what we'll do is we'll go in and open up that machining assembly, and in here we've got our mold. Okay, and we've got our workpiece. So first thing I'm going to do here, I'm just going to define, so we've already defined what machine we're going to be working off here. I'm just going to choose a particular cutting tool to go along with that tool that we're working off. Okay, so we'll just go through the list and pick out a particular cutting tool here. From that then, I'm going to jump over to the milling tab, and we're going to perform a face milling operation. Okay, so I can either choose that from the dashboard or utilize the mini toolbar here and start a face mill. Now, as always, we can go in and define various different parameters for that face milling operation. So in here, I can come in and change things like the step depth. I can reduce that cut feed down to about 1,000, and you see our path getting defined on the left there, and we can change the lace option to an arc connect. Okay. Now, at any point, once you've defined a toolpath, we can come in and preview that. Okay, so we can watch that play through and check the data and make sure everything's working as it should. Or, that was just a simple play of the path. We can run a slightly more visual simulation of what's going on here. So we can bring in both the part, the tool, and the workpiece, and find out how our toolpath integrates, or we can verify what's going on here. Okay. Now, that is for those that you haven't seen, that is a basic setup for any toolpath really within the machining aspect of Creo. Okay, and if you want to reuse these operations, we always have the ability to create what we call an XML template. So this will enable the engineer to come back and grab the same operation to use on another milling tool or another milling component. Okay. So the keen-eyed among you there may have just noticed we've got a new section within the milling tab, okay, which is for high-speed machining. Okay. So a brand new set of tools here, and the first tool we're looking at is just going in, we're creating a roughing. Okay, so we're sort of boring out that material in the center there. Again, we've got all our parameters that we can go in and fill out. I've changed a few there, and the last one we'll go in and set is just a coolant operation. Okay, so or coolant option, and we'll just set that to a flood option. Okay, so we'll hit OK on that one, and we'll move on to another operation here. So the rest roughing. So what we're doing here is we're picking out basically just a smaller tool, and we can go and remove all the excess material that has been left by that initial roughing operation. And Creo will calculate all of that for you automatically. Okay, you don't have to worry about it. And then what we'll do is we'll finally finish up here with a finishing operation. Now, obviously, because we're working within Creo, if we go back and we change our component or our part, our mold's going to update. And all our downstream derivatives, okay, so also our machine paths, so, okay, our tool paths are all going to update if we go back and change our original component. And that's one of the beautiful things about working within Creo. Everything's connected. We're not working with a disparate system again. It's all integrated within Creo. Okay. So we're just finishing up the final tool path here. Again, tweaking a few parameters, and then we'll go ahead and hit OK. So that's pretty much set up now. We've defined all our tool paths. The final thing I'm going to do, if I'm an engineer, I can go back and access one of those XML templates we talked about just a second ago. So that's going to add in 2 new machining operations, okay? And these machining operations are basically just going to drill out those sort of locating holes on the model. So again, if you reuse your tool paths, we can use these templates to save your engineer time rather than having to repeat the same processes over and over again. Okay. Finally then, what we're going to do is we're just going to validate the final processes. Okay, so we'll take a look at, first of all, at the roughing operation, okay, and the face mill, and we'll play those in a bit of a simulation. Okay, so I'm going to bring through my target, okay, and then we'll play that, and we can watch that and run through and make sure that is all running smoothly and as it should. Okay, and we'll run through that. Okay, I'm not going to sit here and watch the animation there. We'll close that off, and then we'll just finish up by watching the finishing process. Okay, and again, I think this will all check for anything like gouges and things like that in your stock. Okay, so obviously we don't want to finish our initial stock. We want to jump in and load up our roughed stock here. So we'll load that in, and then we can go and investigate the finishing operation on the top of that. Okay. So again, bring in our target, and we'll just have a little look at that, and then we'll move on. Okay. Okay. So that pretty much concludes the demo. I know it was a lot of information to go through there. Hopefully we haven't bamboozled you too much. I say if you've got questions, please fire them through. But before we do that, I'm just going to hand you over to James. So I'll say goodbye and thank you very much for joining us here today. It's always fun doing these demonstrations and letting you all get up to speed with the latest and greatest stuff that's happening over at PTC. So thank you very much, and I'll pass you back over to James now.
Hello everyone. Yeah, great work, Rory. That's really good. Thank you for doing that. A lot of subjects covered. As Rory said, what we will be doing over the coming months is dialing down and specializing in some of the areas that you've seen, such as topology optimization, NC, and we may even do some more vignette videos on the core modeling aspects that we haven't managed to cover in this hour session today. As Rory said, the questions, unfortunately, we've got about a minute left of the webcast, so any questions that you have, please still put those through or email them across to us, and we'll make sure that we get back to you on there. And yeah, that's pretty much the presentation for this morning. Hopefully you've enjoyed it. Again, if you're watching this on the replay and you want a copy of the slide deck that you've seen today, then please email us, email me or your sales representative or info@root-solutions.co.uk. or you can catch us on our website as well. So yeah, thank you very much for attending. Hopefully you enjoy Creo 5, get it downloaded as soon as you can. and we'll see you all soon. Thank you for watching. Cheers.